Hello, my name is David Richardson. The past few years, I've been fortunate to share the stage with my friend and colleague Deepak Singh, who leads our container organization. Unfortunately, this isn't a normal year, and instead of being with you and Deepak, I'm standing in a studio in Seattle. I'm sorry we can't be together, but we did want to take advantage of the flexibility of this year's virtual reInvent format. So we decided to do two separate sessions. If you haven't already, I encourage you to watch Deepak's talk, as we know many of you use a combination of containers and serverless to build your applications. So I'm going to focus on how we think about innovation and some of the capabilities we provide to help you build and refactor applications. Now, Andy opened his keynote by talking about how critical it is for businesses to innovate, and he called out a few key things that are required to drive innovation. He spoke about how speed matters at every stage of a business, and the need to simplify and to constantly deliver to solve problems for your customers. And I wanted to call those out because they really are some of our guiding principles in serverless. Our goal is to provide you with capabilities that help you innovate so you can get to market as fast as possible with the lowest possible total cost. Now, we launched Lambda 6 years ago, and we continue to be humbled by how many people have adopted it. Hundreds of thousands of customers have built applications that already drive trillions of invokes per month, and Lambda continues to grow at a phenomenal rate. Now, Lambda may have started serverless, but the incredibly generous community of serverless heroes have turned serverless into a revolution in how to build in the cloud. The team and I love how the serverless community helps new developers and operators learn how to build. So before I talk about what's new, I want to say a big thank you to the entire serverless community for all the feedback you provide. Everything that we launch is shaped by your feedback, and we're looking forward to hearing your feedback about what we've done this year. So why are customers adopting the Lambda programming model? Well, AWS is fortunate to have, hundreds of thousands of years of engineering experience building applications in the cloud, and we've learned even more from our customers. And we use all of this experience to bake into our services the lessons we've learned about building in the cloud. We take the things that are common across all applications, and we build them into our services in a way that they completely disappear, so you don't have to think about them, or at least make them as simple as possible for you to use and control. So there are four key areas where we are always innovating to try to provide those simple, powerful capabilities. First is agility, to help developers and operators move fast. We provide performance to support as many workloads as possible, and low costs that follow your usage. And then we build in and we continuously improve security. And we invest in these areas because we think this is what helps customers innovate. So let's start with how we're innovating to improve your agility. We always start with event-driven architectures, which are the key pattern for agility. Lambda started with 3 event sources, and now we have over 140, plus EventBridge's support for popular SaaS integrations. And we expanded language runtime support from our initial few to currently 12, along with the ability to bring your own. And while we continue to invest in AWS native operability capabilities, including CloudWatch and X-Ray, we know many of you have wanted to be able to take advantage of other tooling ecosystems. And so we recently introduced extensions, which help you monitor using third-party tools just as easily as you can with AWS native tools. And we also just announced support for packaging functions as container images. We have a strong commitment to provide great monitoring and operational capabilities. Back in October, we were excited to work with the CloudWatch team to launch Lambda Insights, and we continue to invest in X-Ray and other capabilities. But we know our customers have a wide range of systems they need to manage, and many prefer to use a single commercial or open source stack to operate both their on-prem and AWS-based systems, rather than mix and match operation systems. So that's why we recently introduced extensions, which makes it easy to use your favorite third-party tools to observe and operate Lambda functions. Lambda Extensions is designed to support the tools you already use today. They're simple to configure and manage, and you have a whole bunch of options. You can use the Management Console or the CLI. You can use infrastructure as code with support from CloudFormation, the Serverless Application Model, Terraform, or the Serverless Framework. And you can even manage and configure them with services, such as Stackery. There are 2 components to the Lambda Extensions capability: the Extensions API and the extensions themselves. So the Extensions API makes it easy to build tools and to get greater control during function initialization, invocation, and shutdown. And we're very excited to have an early group of partners who've already delivered extensions, including Epsagon, New Relic, Lumigo, and Thundra, who've all made it easy for their customers to directly instrument their Lambda functions. The Extensions API builds on the existing Lambda Runtime API, so it works with all supported and the custom runtimes, and it's available to anyone. We're looking forward to how partners and the open source community, and even individual customers, innovate with extensions to make it even easier to operate Lambda-based applications. So we know customers want to standardize on one set of operational tooling. And similarly, we know many are also standardizing on container tooling for packaging their application software. They want to invest in one set of tooling and training for the first part of their software lifecycle, kind of the edit, the build, test, and the packaging phases, which is why we launched the ability to define and package Lambda functions using container images. Our goal here is very simple. We want customers to get the full benefit of their investment in container tooling for building and packaging software, while also getting the same full serverless benefit of Lambda's 140 plus native service integrations, Lambda's simple programming model, the pay-per-use billing, and built-in automated scaling that's more than an order of magnitude faster than cold start scaling in container orchestration systems. But it's not as simple as just supporting the Open Container Initiative format. Along with launching support for OCI images, we've also added support for up to 10 gig package sizes, so you can use large container images such as those that have built-in ML inference models. We've also open sourced the base images for our supported language runtimes, or you're welcome to start from your own or from a community base image. Now, to make starting from your own possible, we've open sourced the Lambda Runtime Interface clients and also a Lambda Runtime Interface emulator that you can use in testing, in local testing such as with Docker Desktop or in your CI/CD pipelines. Now, part of why I wanted to talk about extensions and container image support is just because we're excited about them. The team has been working incredibly hard for over a year to bring these out, and we're eager to see what you do with them. But more importantly, we think both are really key to making it easier to use Lambda. We've spoken with a lot of customers, especially ones who were already using Lambda for pretty critical applications. And one common bit of feedback we heard is that they love the simplicity of Lambda and the low operational burden, but sometimes it takes extra work because it's different. So we spent a lot of time thinking about the ways in which that difference is helpful and beneficial, such as event integrations and near instantaneous auto-scaling, but also the ways where that difference was just different rather than helpful. And that's what led us to the Extensions API, so that Lambda can be directly supported by the whole ecosystem of operational tooling, and to support container images, so that developing and testing with Lambda fits right in with container development. Our goal is to continue to provide all the serverless benefits of Lambda while making it easier to develop and operate using your existing practices. Now, if you chat with anybody who works at AWS, it won't be long before they start sharing some of their favorite customer stories. It's because we love the creative ways customers use our services to build their businesses and to solve their problems. Coca-Cola is a great customer who had to react quickly to the changes brought on by the COVID pandemic. They wanted to provide a touchless experience for their Freestyle drink dispensers. And so they built a new smartphone app that allows customers to order and pay for drinks without coming into contact with their vending machines. Because they built with Lambda, their team was able to focus on the application rather than security, latency, and scalability, since those are built in with Lambda. And as a result, they built this new application in just 100 days, and now over 30,000 machines have the touchless capability. It's pretty amazing the range of applications that can be built using Lambda and serverless, and we're always working to improve performance to support even more workloads. Earlier this year, we launched the ability to attach volumes from our Elastic File Service, so that your functions can make it easy to work with massive data sets and with persistent data. And we also wanted to make it even easier to perform large computation jobs, such as on those data sets. So we've now raised the function limits up to 10 gigabytes of memory and 6 CPU cores. We're also always working on driving down cold start and warm start latencies, and increasing concurrency so that individual functions can run at 1 million or more TPS. And for those times when you want to control concurrency yourself, we offer provision concurrency. Now, all of these performance capabilities are available for both zip packaged and container package functions. And we will continue to improve in these areas because we want customers to focus on launching new applications as fast as possible, not getting bogged down and having to pre-build a lot of scaling capabilities when they don't know how much their application will be used. When we first started planning the provision concurrency feature, it was a very controversial feature. Some people on the team loved it, while others thought, nah, that's not serverless. You can't do that. But really, it came down to simplicity. We're going to continue to invest in reducing cold start latencies and improving auto-scaling. But we know sometimes customers have very specific performance needs. They know better than us. And we saw, unfortunately, those customers were doing all kinds of crazy indirect warming functions and jumping through hoops to try to achieve their performance goals. So we decided the better approach was to give them a simple knob to let them achieve exactly the performance they wanted. And we made it easy to enable or to disable or to reconfigure on any function, an existing function, new function, zip defined, or now OCI defined. And that made it very easy for customers to adopt, making provision concurrency one of our fastest growing features. We think the same way about security. Now, security is job one at Amazon, and we bake it deeply into all of our services. And our first goal is to take on as much of that shared security responsibility as we possibly can, such as by handling patching and achieving a wide array of compliance certifications. We've innovated deeply into the security space as well, particularly with our open source hypervisor, Firecracker. With Lambda, from the very start, we've wanted to provide the strong isolation boundaries of virtual machines, but with the agility of containers. So AWS built Firecracker, and we open sourced it, so that customers can deeply inspect these security guarantees and the whole community can benefit. But just as with provision concurrency, we know there are some things you want to control yourself. And so we also built in very specific security controls. We have the full richness of IAM, including allowing you to set org-wide guardrails, and you can pre-configure security in CloudFormation stacks, or you can define audit policies using CloudTrail, Config, and GuardDuty. Now we have a few additional things on the security front. Earlier this year, we updated the AWS Well-Architected Guide with a serverless lens, providing enhanced guidance on security best practices, along with operational and cost management best practices. And now we're adding VPC access control support for Lambda functions. Lambda functions have for a long time been able to be integrated inside of a VPC, and now we've made the ability for you to enforce that it's only accessed from a VPC. On top of that, we're now launching code signing for AWS Lambda. For our customers who've wanted full control over the end-to-end provenance of their function code, we've also added deep integration with AWS Signer and KMS. Now, we're also innovating when it comes to lowering costs. For most applications, most of the cost actually comes from the expensive engineering time required to build and to maintain applications. That's why we have such a strong focus on innovating to help you get to market faster with lower operational burden, because reducing the effort involved in launching and supporting applications directly reduces your costs. And for most customers, for all but the largest applications, development and operations are likely the largest part of TCO. But we also innovate on the infrastructure side to be able to pass on lower unit costs. It starts with built-in auto-scaling and pay-per-use models available across all of our serverless offerings. Most enterprises struggle to drive better than about 10% utilization, maybe 20% for their biggest, most well-operated applications. And you'll read a lot of literature about that. But the funny thing about utilization is most people overestimate how well they're doing, and they underestimate how hard it is to drive utilization. I joined AWS back in 2006, and I have to admit I'm glad nobody asked me about server utilization during my interview, because I would have gotten it completely wrong. I think if you had kind of asked me about that back then, I probably would have guessed we ran servers at about 50% utilization, to support peaks about double the average traffic. And if not, probably only a few software tweaks to get up to that level. But early on, after joining the team, I realized how far that was from the truth. And for about the past 10 years, I've reviewed our utilization efforts nearly every week. And driving utilization requires work up and down the stack. We've worked with our hardware partners to modify SSD firmware so we can tune the ratio of performance and storage to fit our workloads, to better balance out our use of those offerings. We work on the supply chain to reduce lead times. We fine-tune our Java and other language runtimes to reduce garbage collection overhead. And we invest heavily in data science to develop algorithms and ML models for placing workloads together so we can simultaneously drive up utilization while improving availability and reducing performance jitter. We actually celebrate improvements that are at the level of tenths of a percent. And it's some of the hardest work we do. I also have to admit, it's kind of some of the most fun too, because we get to work with people across so many different disciplines to drive these kind of improvements. So one of our goals, though, is to take on the burden of that continuous work required to drive high server utilization and pass it on to you. And so that's why we are now passing on the benefit of that utilization work by reducing Lambda's billing granularity down from 100 milliseconds to 1 millisecond. This can provide up to 70% cost savings for some functions, such as short-running functions, the kind that are used to handle human interactive workloads. We know part of agility is being able to change your mind, and that's why we added Lambda to compute savings plans. We want customers to have the flexibility to change their compute architecture between instances, containers, and functions without any risk of stranding their savings plan financial commitment. Savings plan automatically applies the best possible discount across all of your compute usage. Now, it's never easy to compare costs between different architectures. You have to make some assumptions. And many times those assumptions are subtle or they're hidden. With serverless, we try to make it simple by billing at the individual message or request or bit of compute. And we build into those prices all of the auto-scaling, the load balancing, and the fault tolerance you would have to build, operate, and pay for separately in a traditional architecture. So when you think about alternatives, make sure you include all those costs. And you think about utilization not in days or weeks, but in milliseconds. So combined, our goal with all of these pricing improvements and our agility improvements is to help you get to market fast with the lowest possible TCO. Now, we've called out several of the reasons customers are adopting serverless and how we're innovating in those areas, all with the theme of agility. We want to be agile so we can move fast and so we can react and adapt to change, which has been more critical this year than ever before. Think about reInvent this time last year if you were there. I don't think any of us could have predicted what was about to happen just a few weeks after the conference. So to talk about serverless technologies and reacting to change, I'm pleased to welcome Lavanya from Capital One, who will share how they responded to unique challenges brought about by the pandemic.
Thank you, David. Hello, everyone. I'm super excited today to talk to you all about how we at Capital One are leveraging serverless in our contact center implementation. I head technology for our servicing line of business in Auto Finance division. Our goal at Auto is to make sure that we keep customers in their car and make car ownership hassle-free. When we were designing the contact centers, the primary goal was to make sure that we could scale easily to the voice traffic and also to keep it modular and flexible for us to add new features and implement it with a faster time to market. With that in mind, we architected our call centers with Amazon Connect at its core. When a customer makes a call and interacts with the interactive voice response system or directly makes a call, the call first goes to the voice service provider and then gets routed to Amazon Connect, at which point we have multiple Lambda functions fetching the call contact, to fetch the customer account details, and also to fetch the queue and the agent details so that we can have the right agents talk to the right customers. In short, we leverage Lambda functions to orchestrate our call flow. After the call, we also leverage Lambda functions to help with downstream processing like call transcriptions and also call tracing. With this architecture that we implemented last year, we were able to actually tackle the call volumes that we have easily and then achieve high service levels. Until recently, earlier this year, when COVID hit and the whole world changed around us, with nations across the globe going in lockdowns, with people losing jobs and unemployment soaring really high, there were a lot of things that we had to tackle as our lives were changing. At the same time, our call centers started experiencing 5x increase in call volume. Not only that, our staffing was reduced to less than 50%, and customers were going through hardship and desperately wanting to talk to us and making calls again and again, which increased the call wait time to closer to 4 hours, and that impacted our service levels as well. We knew we had to do something, and we had to do something really, really quick. What did we do? Leveraging the serverless enabled us to focus on the core needs and not worry about the infrastructure scalability issues. We could focus on two things. One, to get our agents get to work from home really, really quickly so that we can get the staffing back up. And we focused on implementing new features like callback, queue depth, call waiting time, and self-serve features so that we could deflect some of the traffic to self-serve. In the older architecture, if we had to do all this, it would have taken us weeks, if not months. With this architecture, we were actually able to get it done start to finish from March 15th to end of March. By April 1st, our call volumes still stayed high, but our service levels were back to normals. We were 85% up in staffing, and we could bring down the call waiting time from 4 hours to less than 10 minutes, which was huge for our customers and how we were able to serve us at the right time when they needed us the most. When customers who lose their jobs and going through hardship in these tough times tell you you are a human well-being first company and you really actually care, you know that you're doing the right thing for them. And as a technologist, that's a proud moment for you because you know that you've architected the system well that could stand the test of times. Thank you.
Thanks, Lavanya. And we're glad serverless was able to help you deliver these great benefits to your customers. We're always excited to hear what customers build with serverless. One thing we've been thinking about a lot this year is not just how do customers build individual applications, but how do they adopt serverless as one of their core building blocks for multiple applications? What does that adoption journey look like? We've spoken with a lot of customers, and getting a better understanding of the whole journey helped us realize we needed to build things like Lambda extensions and Lambda container images, because we saw that we could simplify adoption by being compatible with existing tools. But what does it look like as customers start building new applications? Startups are a great example of what's possible when building something new. For example, Steady built a commercial trading network to automate trillions of dollars in B2B transactions, and they did it with a serverless first strategy. So now they're ready for whatever scale comes their way. As Zach mentioned, they chose serverless to minimize operations and to be able to scale to any size. Serverless first is a strategy adopted by many of our most successful customers. They challenge themselves to build all new applications based on serverless. And this is important because building for scale is hard. The truth is, whether you're a startup or an established enterprise, it's almost impossible to know whether your V1 is going to be a hit and scale to serve millions of customers or if it will have more of a niche audience. And building every V1 to perform at a high scale, high performance way is really hard work with traditional architectures. It's time consuming. I can tell you that these are some of the hardest product decisions our teams have to make inside of Amazon. If there's one thing we've learned about innovation, it's that the best way to learn how to truly help customers is to launch and iterate. As Andy mentioned, speed matters. But for each iteration, we also have to predict how fast it might grow. And we have to build to be ready for that growth before we launch. If we've overbuilt, that's lost time and expensive engineering and infrastructure that could have been put into other iterations. If our prediction was too low, we'll get ready for a success problem and a lot of long nights to get caught up. So that's why we put so much energy into the scalability of serverless, so that rapid scaling and high availability are built in, even if you are surprised by your own success. Our goal is to let you focus on the business logic, and we'll focus on scaling and availability. Now, I got a little bit ahead of myself when I mentioned serverless first. While that is the strategy that helps our customers get the best time to market and TCO benefit, most don't start out that way. We often see customers first go through 3 distinct phases of adoption. They often start out with IT automation, such as using Lambda functions to validate some configuration each time an EC2 instance is launched. Next, individual teams might start using Lambda integrations with S3 or with Kinesis streams to build data processing applications. And then, as experience spreads, multiple teams will start building whole microservices-based applications. One thing that is common across all of these stages of adoption is they follow the design ideas of the internet and the web, small pieces loosely joined. All of these applications are modular, composed from multiple AWS services, and customer-developed components. It's why we're so focused on delivering lots of integration in Lambda and EventBridge and API Gateway and step functions. We want to make it easy to build new applications and functionality through loose coupling with other AWS services and your own components. It often starts with APIs managed by API Gateway as kind of the application front door. Often events or messages are the communication system in the back end, all coordinated with workflows. The other common element of these architectures is that they are event-driven. I think of this as kind of the back to the future design pattern dating back to enterprise message bus patterns of the late 80s and 90s. Those same event-driven architectures are relevant today because they're ideal for agility. They lead to loose coupling. They're a natural pattern for how one system reacts to changes in another, and it provides great support for building new capabilities or refactoring existing systems. This is why customers often start with IT automation. As events impacting your business or even your IT infrastructure occur, you can react automatically. Customers often move from IT automation to data transformation workloads. One of the important benefits of Lambda is that it responds to data in near real time, and as customers create more data streams, a serverless approach to processing this data is super attractive. Nielsen Marketing Cloud is doing this at incredibly high scale. They're using Lambda to process 250 billion events per day, all while maintaining the quality, performance, and cost using a fully automated serverless pipeline. The scale of their system is really neat, and it's why they opted for Lambda. So on a peak day, Nielsen received 55 terabytes of data that they processed with 30 million Lambda invocations, and their system managed it with no problem. It just scaled up to 3,000 concurrent Lambdas, compared to a normal day where they only see 1 to 5 terabytes of data. And those also automatically scale. So it moved through that whole range without requiring on-call engineers to come in and do work. Now, Nielsen passes data along to their advertising partners. And as they improved the scale of their own operation, they found it was a challenge for their ad partners to keep up. And so then they also built in a set of Lambdas for rate limiting. And those Lambdas can work for partners based on file sizes, speed rates, and requests, or other areas. So processing Kinesis and DynamoDB streams are some of our most popular workloads. We want to make those workloads even easier, so over the last few years, we've added additional support to simplify working with streams, such as auto-sharding. And now we've also added support to do stream aggregation over windows of time. So you can do operations such as count, max, min, average, and sum. So finally, organizations are increasingly adopting a serverless architecture as their core application design pattern. Often, this looks like Lambda serving as the core compute service of a modular or a microservices architecture. And this can be for a whole range of applications, from web and mobile backends to HPC, even for financial simulations, which I will admit came as a surprise to me. I was working on one of our other lower-level AWS services when Lambda launched. And right away I could see that Lambda would be a great fit for IT automation and for data transformation workloads, but I was skeptical it could do much beyond that. I didn't have any idea how broadly applicable it could be. Oops, that was a mistake. I learned a bunch from our customers who had already figured out that they could use Lambda to build entire applications long before I realized what it was capable of. And I think my mistake was that I didn't realize how powerful Lambda's event-driven capabilities are and how easy it is to solve most business problems using event-driven architectures, which is kind of embarrassing because I knew that many of Amazon.com's core systems had been built using event-driven patterns. And those were all very adaptable applications that were able to grow and to change with the rapidly changing needs of the Amazon.com business. I think in retrospect, I was just too focused on the traditional architectures I was responsible for. So we sometimes debate how to talk about these patterns. Should we call it reactive applications, or talk about it as triggers, or serverless microservices? I'm probably the one who starts a bunch of these conversations because I'm nervous sometimes that others might have the same reaction I did originally to event-driven, and think that maybe these patterns are only applicable to a narrow set of use cases, which is not what we want people to think. We want them to believe that they can solve as many workloads as possible with Lambda. But I think we'll just trust our customers, who have already figured out that event-driven architectures are powerful and simple, and they're a natural way to build a huge range of applications. So customers like BBC have taken this approach to their websites. Until recently, much of the BBC website was written in PHP and hosted in 2 data centers near London, which was a pretty common choice when it was made in 2010. But things have changed, and BBC has been rebuilding their entire website to improve flexibility, scalability, and speed. And they've done this with a modern modular architecture, leveraging a serverless strategy. They have a great blog post about what they did, and I encourage you to go take a look at it. And if we look at one example, they have nearly 2,000 Lambda functions that run every second to render web pages for the BBC website. It's a number that they expect to grow, and BBC chose Lambda to reduce their operational and maintenance costs as well as to scale. So when there's a breaking news event, their own traffic levels can rocket, and Lambda can scale up to easily handle this. It's pretty common for modern cloud applications to be composed of many services and components. And as applications grow, an increasing amount of code needs to be written just to coordinate the interaction of all the components. I can't tell you how much engineering effort inside of AWS gets put into things like retry logic, back-off algorithms, and tuning receive queues. So this is where managed workflows can be very helpful. They let you focus on defining the component interactions more at a logic level, rather than having to write all the software just to make the interactions work. Step Functions is our serverless cloud-scale workflow service. Like all of our other serverless offerings, it has a rich set of integrations to work with other services. And we're continuing to expand it to cover more workloads. Originally, Step Function was optimized for very durable, long-running workflows. It could support workflows lasting up to a year. Then last year, we launched Express workflows, which were optimized for low latency, high volume, low cost, and async workflows. So this year, naturally, we are expanding again with synchronous Express workflows. So these are also optimized for high volume use cases, but now synchronous ones, such as human interactive workloads, still with the same low costs as async workflows. It's pretty easy to see how serverless makes sense as the way to build new applications. But applications are rarely completely new. More often, customers are busy refactoring existing workloads, either to keep up with scaling or as part of delivering new features. So broadly, our customers have a few options. First, always best, just reduce. Retire whatever stuff you can that you're currently directly responsible for, and adopt SaaS in other places. Next, do a lift and shift. Do a migration to AWS, and most customers benefit from doing this quickly to get out of data center management and onto a common platform. And then when it comes to modernizing, when we talk about replatforming, what we really mean is moving from a service you manage yourself to a service that AWS can manage for you, such as moving from a self-managed database to RDS, or from self-managed RabbitMQ to adopting Amazon MQ. And then finally, refactoring is really where our customers see the biggest transformation. Successful customers start by refactoring their most critical or customer-facing applications, because that's where you'll get the most time to market and TCO benefit. Okay, so that's a high level. To get into specifics, I'd like to invite Vishal to share how Discovery Golf modernized by refactoring.
Hi everyone, I'm Vishal Parikh and I'm the head of product at Discovery Golf. Today, I'm excited to share with you our experience refactoring to serverless. Discovery is a globally leading media company which has a tremendous variety of content across more than 90 brands of real-life entertainment and sports content. These brands that you may recognize include Discovery Channel, Food Network, and HGTV. Discovery is putting a significant amount of focus and investment into the direct-to-consumer industry, which means customer experience is always our top priority. Discovery Golf within Discovery encompasses Golf TV powered by PGA Tour and Golf Digest. Golf TV is a streaming service that streams live golf coverage from PGA Tour, European Tour, and other majors and events, and it's available in almost every territory in the world. We were ambitious and we built the Golf TV streaming platform within 4 months and launched in January 2019. Since then, we've had a lot of platform growth, including new sources of content and data. The platform was built by one company using a proprietary digital ecosystem, including front-end applications, as well as all the back-end systems and integrations. While this worked originally, as we scaled, it was increasingly challenging because everything was a black box for us. We had no control over our user experience, we couldn't solve our customer-facing issues fast enough, and we couldn't add features and functionality to grow the business easily enough. We needed to take control of our destiny, and we wanted to start with the user experience first. Golf TV has some unique challenges. We have traffic spikes at unexpected times from different regions. There are obvious spikes during golf tournaments over the weekend, but for us, that is intensified by regional and global spikiness. For example, when Hideki Matsuyama was doing really well at the Masters, we immediately started seeing more users hit our platform from Japan. We need an adapted environment and infrastructure to support rapid and unanticipated changes. We also needed the ability to aggregate data from a variety of different sources like tour partners, content management systems, live leaderboard data coming from different tour partners, schedule and broadcast information, as well as article and editorial content from Golf Digest. We integrate all of this with our user management and subscription management platforms that power critical functionality for our users. And we wanted to build this system in a way that would enable us to connect back to legacy systems so that we could continue to leverage the existing backend technologies. We ultimately chose to refactor to a serverless architecture because we knew we had a small team and we wanted to focus on the user experience and needed to enable them to spend more on that core product instead of worrying about things like scaling, provisioning, or availability. We also knew we wanted to move incrementally, building serverless middleware that would give us the ability to change out backend infrastructure and systems in the future. For us, that started with a decision to adapt a React Native front-end framework, and so we use AppSync on the serverless side because of its support of GraphQL APIs. We then chose to connect AppSync to Lambda, which is responsible for getting data from a variety of different data sources, including DynamoDB, Elasticache, and third parties for content and metadata. Lambda also supports direct Lambda resolvers, which make it easier to work with Lambda and GraphQL on AWS. So how did this work for us? We were able to build this new system and integrate about 40% faster. We were able to reduce our estimated cloud costs by more than 15%, and we were able to save between 12 and 20% on the engineering costs that were required to actually build the approach compared to other alternatives. What's even more exciting for us is now we can respond to our customers' needs faster and more easily, including things like getting users to the live stream easier and faster and having leaderboard data in real time next to the live stream. Looking further ahead, we're excited that a serverless first strategy has enabled us to remain what we call future flexible, because nothing is actually future proof. By decoupling the front end with the back end of the system, we can use more of Discovery's existing global technology platform without rebuilding the front end again and again. This means we can grow and adapt quickly where opportunities arise, swapping things in and out as the business changes. For example, we can scale up automatically for unpredictable traffic spikes, adapt to new data sources quickly, or even add features for new revenue streams faster. We're happy with the path that we chose given the increase in engineering velocity, the reduction of cloud costs, and the estimated reduction of cloud cost to implement compared to a non-serverless approach. And the best part is, we're just getting started. With the technology decisions we made, the Golf TV business can explore new lines of business and revenue streams like tee times, travel, and more. Because a serverless strategy enables us to easily connect to new data sources and react to whatever comes our way. We can ultimately apply what we've learned at Golf TV to other areas of the business and start seeing all those cost and scalability benefits at an even bigger scale. Thanks.
Thanks, Vishal. One of the things Vishal mentioned is how Discovery Golf was able to refactor one application while remaining connected to the rest of their technology platform. This type of integration challenge is one of the most common questions we see from customers, which is why we continue to invest in making that integration process easier. Many of our cloud-native and our hosted offerings help connect your existing technology stack into the cloud, and we're continuing to invest to make this easier. Some of the recent additions include Amazon MQ now supports Rabbit along with Apache ActiveMQ. And now you can also trigger Lambda functions with Amazon MQ, making it easier to build serverless applications. We've also added integrations between Lambda and Amazon Managed Kafka or MSK. Last year, EventBridge added support for events from popular SaaS partners, along with their existing support for AWS and custom events. And API Gateway has long supported integration with both AWS services and with your existing on-prem platform via Direct Connect. And now, for those who want a hosted workflow offering, we're launching Amazon Managed Workflows for Apache Airflow. We were pleased to launch Amazon Managed Workflows for Apache Airflow just ahead of reInvent because customers love Airflow workflows because of its active open source community, its large library of pre-built integrations to third-party data processing tools, and the ability to use Python scripts to create workflows. So now, with Managed Workflows for Apache Airflow, we can cover the operations and the management challenges, allowing your data engineering and developer teams to focus on research and development. As we've spoken about, to innovate, businesses need capabilities that help them move fast, build simply, and deliver rapidly to their customers. At AWS, we talk a lot about builders, and we see both developers and operators as the critical builders in a serverless-first strategy. Many of our new capabilities, such as Lambda extensions and VPC access controls, were built specifically for cloud operators. Because many times operators are the first to adopt Lambda, and that's because of how Lambda simplifies their IT automation responsibilities. And features like larger Lambda functions and synchronous express workflows were built to help developers build faster. These roles are changing as customers move to the cloud. And our goal is to build capabilities that help operators and developers be successful as their responsibilities change. I think what is particularly interesting is the collaboration between operators and developers. How do they work together to build and operate modern cloud-native applications? So one of the growing collaboration patterns is the Cloud Center of Excellence or Cloud Platform or Shared Services Platform. It goes by lots of different names. Operators want to share best practices and enforce security policies and their operational tooling in a way that's efficient and standard, but that doesn't restrict developer freedom and agility. One of the core tools for doing this is infrastructure as code, which allows operators to capture best practices and policies into templates. Container images also work well in this collaboration, as they fully encapsulate application code, and they can be managed with tools like the Elastic Container Registry and are easy to reference by infra as code. So we built Lambda extensions and Lambda container images to support this type of developer-operator collaboration, and we support all of these features with infrastructure as code capabilities in CloudFormation and SAN. Now, getting the operator-developer workflow right is critical. If you get it right, it becomes easy to have healthy security and governance and share best practices without requiring each developer to go figure them out on their own. If you get it wrong, you're back in the old days of central IT as friction instead of as a source of speed and agility. And that's why the container and serverless teams built Proton. It's the first fully managed deployment service for container and serverless applications. And we want to make it easy for operators and developers to collaborate together to help those central infrastructure teams define architecture templates, we call them stacks, that embody all of their best practices, their operational tooling, and their security policies. And then make those available to developers who can add their business logic via containers and Lambda functions. And then Proton's integration with the CI/CD pipeline gets your applications and changes into production. It configures the pipeline and monitoring, all without the developer needing to configure the underlying AWS resources and dependencies. Proton gives your developers an easy way to deploy their code in a way that enforces architecture and security standards while still letting them move fast. The way it works is that central infrastructure teams build stacks in Proton that define everything needed to provision, deploy, and monitor their application components. Then, whenever a developer is ready to deploy, they select the right stack in Proton and connect it to their code repository, such as GitHub. Proton automatically provisions all the infrastructure resources, configures the CI/CD pipeline and the monitoring tooling, and deploys the code into the new infrastructure, all without the developer needing to configure the underlying AWS resources or dependencies. Proton handles all of that and abstracts it away. Infrastructure teams can also update the stacks in Proton. Proton identifies out-of-date deployments and makes it easy for teams to centrally push out those updates, filling a major gap in how infrastructure and code deployments are managed today. Some people say it's turtles all the way down. I tend to think it's grilled cheese all the way down, but really it's innovation all the way down. Our goal is to help you innovate. We think serverless is the way you can get to market the fastest. And so when we think about where and how to innovate, we do it based on what will most help you innovate. We think serverless provides the most agility, now enhanced with new Lambda extensions and OCI support, provides performance to meet a broad array of workloads, now expanded with 10 gigabyte functions, provision concurrency, and auto-scaling that's faster than any container orchestration system. Provides the lowest TCO, now with 1 millisecond billing and flexible savings plan. And to support loosely connected systems, it provides 140 integrations, as well as integrations with your SaaS and your existing tech stacks. We're incredibly thankful, and we're inspired by the hundreds of thousands of customers who've built using serverless, especially by customers like Capital One, Coke, Steady, Nielsen Marketing Cloud, BBC, and Discovery, who shared their stories today. So we've just launched a whole bunch of stuff. We're super eager to see how you use it. That's what inspires us. So don't wait, just go get started and go build.